Okay, so welcome to the video for Advanced Maths or Mathematics 2 unit on differentiating and integrating. One of the most important things to be able to do to get a band 6 is to confidently be able to differentiate and integrate anything. So what I've created here is a little table, and you can email me. My email is on my About page on YouTube here if you would like the PDF or Word document version of this document. Otherwise, the document is just a summary on differentiating on the left-hand side and integrating on the right-hand side. Algebra, fractions, logs, exponentials, and trig. So they're the 5 different things there that you do need to know how to do and do very well in terms of differentiating and integrating for the Advanced Maths course. So let's start straight away. Algebra. What I've written there in blue is just my version of the summary of how to do it. Okay, so you can pause the video and give these a go. Otherwise, jumping into it, the left-hand side we're differentiating. So I've said to differentiate algebra, you multiply the indice out the front and subtract 1 from the power. So if I do that, I'm going to end up with something that looks like this. Now, notice what I did there. I took one more line to just rewrite my my surd there with a power, so it cleans things up a lot nicer when I go to differentiate that, and the marker can clearly see what I've done, where I've got my numbers from. And don't try and just do something like that in your head, because it's worth taking an extra minute to write that line so that you don't make just a silly mistake. So all I have done is multiply the indice for each one out the front by whatever the coefficient of x is, then subtract 1 from the indice. So that's all you're going to ever do to differentiate algebra. So then to integrate algebra, it's just going to do the exact same thing, but the opposite. So instead of subtracting 1, we add 1 to the power and then divide by it. The important thing here to do is to, once again, add 1 first and then divide by it. Whereas when we differentiate, we times it out the front, then subtract it. So integrating, add first, then divide. So I'll take this time, rewrite out that line. You'll notice the exact same question. So going from the line over here on the left that I already wrote out, add 1 to the power, then divide by it. So when I do that, I'm going to get this line here. So once again, added 1 to the power and I divided by it. Added 1 to the power, divided by it. The surd becomes a bit ugly, but think about adding the number 1 to the number a half. The number 1 is really 2 over 2. So when I add 2 over 2 to 1 over 2, I get 3 over 2. But otherwise, that's the same thing as 1.5. And then I divide by it. Then adding 1 to the negative power, be careful of that. To the x to the power of negative 4, if I add 1 to that, it's going to give me negative 3, not negative 5. Then I add a pronumeral to my constant and then add my plus c. I am going to clean this up a little bit here. It's important to know how to do simple fractional rules in your head and not just rely on the calculator. Cleaning something like this up, I'm just going to show you on a side note. X to the power of 3 on 2 divided by 3 on 2, I'm going to write like this. Think x is really over 1. When I'm dividing two fractions, I flip and times. So that's going to be x to the power of 3 on 2 timesing by 2 on 3. And the better you get, the quicker you get, and you will be able to see these sort of things in your head eventually. So then I'm just going to end up with 2x to the power of 3 on 2 on 3 as my answer. So you will eventually get to the point where you just know, okay, dividing by a fraction, flip and times. So I'll take one more line to write out what that is in a simplified form. And something I didn't mention is I always write my answer back in the form they gave it to me. So they gave it to me with a negative indice, so I leave it as a negative indice. They gave it to me though with surds involved, so I put it back in form of a surd. Not a must, but it's just something that I usually do. All right, fractions. Fractions can be tricky because people get confused whether it's a log or whether it's not. So what I have written here, to differentiate a fraction, bring the denominator up as a negative power, multiply the indice, subtract 1, and then multiply it by the derivative of the brackets. So that's kind of like your chain rule. So ignoring logs for a second, and then I will get to logs and I'll show you what to do in terms of whether it is a log or whether it's not a log. So looking at this question in particular, I'm going to bring it up as a negative power to start with. Once I've rewritten it like that, not doing it in my head, I'm writing that out. Now is when I say, okay, well now my derivative. Follow the steps. I multiply the power out the front, okay? So I'm going to have negative 2 outside of x plus 3. Now subtract 1. Same idea. The last step you have to do though, the new part for a chain rule, is multiply by the derivative of what's inside the brackets. So the derivative of inside the brackets, the derivative of x is just 1. So it's going to just be multiplying by 1, which isn't going to make a difference. Once again, I'm going to write it back in the form they gave it to me in. So I'm going to have negative 2 is over x plus 3 cubed. Okay, notice my negative 2 stayed because it has its own power of 1. It's not affected by that negative 3 power. Okay, now integrating. I'm going to do the exact same thing but in the opposite form. For instance, I've written here, bring the denominator up as a negative power, add 1 to the power, divide by it. Then divide by the derivative of the brackets. So once again, I'm going to go from this line here that I've written out already. My integral says I add 1 to the power first. So I'm going to have x plus 3, add 1 to the power to is negative 1. I divide by that. So it's the same as integrating with algebra. Add 1 to the power and divide by it. But I'm also going to divide by the derivative of the brackets, okay? The derivative of my brackets is once again 1. So I'm going to divide by 1. When I'm dividing by 1, it's multiplying by what I already had underneath there, which then gives me an answer of just negative outside of x plus 3 to the power of negative 1, which is in a nicer form, just that. So it's what I call the chain rule of integration. You've got the opposite, you're undoing what you did when you're differentiating. All right, differentiating logs. What I've written here, put the derivative of the bottom on top and the log drops away. So all you're going to do is differentiate what's in the brackets, put it on top of it, and the log drops away. So for instance, what I'm going to have here, the derivative of the brackets is 2x. It goes on top of the brackets and the log drops away. If you can simplify in any way here, you always should. However, I can't, so I will leave it as that. Integrating logs is a little bit more tricky. When we're integrating logs, we say to ourselves, is the derivative of the bottom on top? If so, then just log the bottom. If not, manipulate the front of the integral. So my first is an if so example. I see a fraction here. Now, I know this is a log integration because I've put it here in the log integration. If this was your HSC though, people get confused between, well, what's the difference? How do I know if it's going to be an integration involving the chain rule, because that's also got fractions in it, or if it's going to be an integration involving logs? Because they both involve fractions, however, they're both done in very different ways. So what I'm going to show you right now is how you know if it's a log integration or whether it's going to be your chain rule integration. My first tip is if there is a letter on the top in advanced maths, it will always be a log. There is no way that we learn how to do integration in advanced maths with an x on the top and the bottom. So as soon as you see there is an x on the top and the bottom, and the x can't cancel in any way, it's going to be a log integration. That's like a little cheat rule. However, the other way to know is if the power of everything on the bottom together is 1. The reason behind that is, let's say that that wasn't an x on top and you had just a 2 on top, for instance. in this case, it wouldn't be that way. But if, for instance, it was, what you would then have is when you bring this up, and you'd have 2 outside of x squared minus 1 to the power of 1. Sorry, to the power of negative 1, because you're bringing it up. When you add 1 to the power, because that's what you do to integrate by chain rule, add 1 to the power and then divide by it. When you go to add 1 to the power, you're getting 0, because minus 1 plus 1 gives me 0. When you get 0 as the power, something's gone wrong. And what that means is, ding, 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 it's a log question. So the point is, you see the fraction. You go to do you go to do a chain rule integration. You bring the power up as a negative and you add 1 to it. When you add 1 to it, if you get 0, it's a log every time. Otherwise, if there is an x on the top and an x on the bottom, it's also a log. So maybe make a note of that. All right, anyway, let's go back to just logs. We know it's a log because we have an x on the top. Yep, it's a log. Is the derivative of the bottom on top? Well, what's the derivative of the bottom? The derivative of x squared is just 2x, and the 1 would drop away. So yes, the derivative of the bottom is on top, so it's an if-so question. So what do? I just log the bottom. Now, it just depends on whether you do log e or ln, doesn't matter. But I'm an ln person. And don't forget your plus c. All right, let's have a look at what happens now if it's an if not example. And if not, what do? It says manipulate the front. And when I say the front of the integral. So let's just see. The derivative of the bottom of this one is 2x. So I'm just going to write what I want it to be. That's what I would like this integral to be, because the derivative of the bottom is on top. But it's not that, it's 4x. So to make this 4x, they would multiply that by 2, because then 2 timesing in here by my 2x would give me my 4x. So now I can just rewrite it like that. This integral that I've rewritten here is the exact same thing of what's above it, because 2 timesing by 2x gives me 4x. Now the derivative of the bottom is on top on the inside though. So it's just going to be 2 lots of log the bottom. So let's just manipulate something out the front. Same as this one. Is the derivative of the bottom on top? No. Write what you want it to be. I want that to be the question. It's not though. So what do I have to put out the front? So when I multiply it in here, I get 3. I need to put a third out the front. So now I have a third log the bottom plus c. All right, exponentials. Exponentials are easy. So all you have to know for an exponential is to differentiate. You just differentiate the power and multiply it out the front every single time. So my derivative of this one is just going to be differentiate the power. It's going to be 3 times it out the front, and we don't subtract 1 from the brackets, from the power. To integrate, we differentiate the power, and this time we divide by it. So that should be an integral, sorry, which gives me 1 over 3 e to 3x, or you could also write it as e to the 3x on 3. Either one of those is fine. Differentiate the power still, then just divide by it. The last part is trig. Now, a handy little thing to remember, even though you do get given it on your reference sheet in a certain way, a good way to think about your sine, cos, and tan, or your sine and cos, thinking about how they differentiate and integrate. I've seen a student of mine do something like this. Sine, cos, negative sine, negative cos. If you write that out, now what you say is sine differentiates to cos. Cos differentiates to negative sine. So negative sine differentiates to negative cos. And then it can work the other way. Negative cos integrates to negative sine. Negative sine integrates to cos. And cos integrates to sine. So you've got your derivatives now and then you got your integral. So if you just remember sine, cos, negative cos, you can remember what they integrate and differentiate to in terms of the sign. Otherwise, what I've written here to differentiate trig, you differentiate the brackets, you multiply that out the front, and then you just change the trig. So let's have a look at this one to start with. So the derivative, I differentiate the brackets, I get 3. I multiply that out the front, then I just change the trig. Now sine differentiates to cos, so then it's cos 3x. So once again, differentiate the brackets and times it out the front. So I'm going to have 5 timesing by 4. Cos differentiates to negative sine 5x, which gives me negative 20 sine 5x. And the last one, this one's just one that is given to you and not hard to remember. Tan differentiates to sec squared. Differentiate this. Now remember, x on 2 is just the same thing as a half x. So the derivative of a half x is a half. I times that out the front and change my trig. And there's my answer. So it's not a hard thing to do. Just remember, differentiate the brackets, multiply it out the front, change the trig. So now integrating, same idea. However, instead of multiplying out the front, I divide it out the front. So differentiate the brackets, divide by it, and change the trig. So this one here. Now these should all be technically instead of y equals integrals. All right, I still differentiate the brackets, and I get 3, but I don't multiply by, I divide by. So you can think of it as a third. Then change the trig. Sine integrates to negative cos. Or you could have just had it all on 3, doesn't matter. All right, next one. Differentiate the brackets is 5. Divide by it out the front. Change my trig. And cos integrates to positive sine plus c. This one here, a bit interesting this time. Again, derivative of the brackets is a half. I divide by it out the front. Change my trig. And I'm going to clean that up. Once again, earlier on I said if you're dividing by a fraction, you flip and times, which will be just 1 timesing by 2 over 1, which will just give me 2. And there we have it. There's a very nice brief summary on how to differentiate and integrate everything you need to know in advanced maths. Don't forget to email me if you would like a copy of this page here.